So here are the solutions to the holiday homework on these topics here. So let's get straight into it. So we're looking for the range, what can come out of this linear function given this domain right here. So let's get a quick idea of it. So negative 2 goes in here and becomes 7. That value is included, so we're going to close circle that. When 7 goes into it, so when x is equal to 7, the y value will be negative 2. That's not included. There's my linear function. So the lowest value I can produce is negative 2, but I can't actually produce negative 2 itself, but I can produce all the values up to and including 7. So negative 2, 7. So it looks like that one is A. Right, lots of students got this second one wrong. Okay, so to show you what most of you do with that one, so let's get rid of this, edit, clear all. Okay, so what a lot of you will do is go ahead and define the function. That should be pretty fast. F of x equals x squared take 2x take 8. Then you bang in the endpoints, so f of negative 2 and f of 3, and essentially presume that the range is between negative 5 to 0. So that would be the most, an incorrect answer there, obviously. Right, so how do you do these ones? Well, I think the best thing to do is to actually try and have a look at this function. So I'm just going to go over to menu, graph and table, and let's just clear that stuff out. And what I'm going to do, I've already got f of x defined, so I'm just going to say, can you graph f of x for me, please? All right, so there it is. And if we have a look, we've got negative 2 here, so that looks like it's 0. And we've got 3 here, which looks like it was negative 5. But actually then it's going to be the values from here, from negative 9 all the way up to this 0 here that can be produced. Okay, so essentially this graph looks as follows. So it's got, what was 3? 3 looked like negative 5 or something like that. I don't know, something like that, not included. Goes down to negative 9, which happens at around about 1. Again, I'm not worried about the x values, but I'm going to swing down like this, turn there, kick back up again, and at negative 2, it's going to be 0, which is included because of that. So our range is actually going to be negative 9 included, because it can produce the turning point, all the way up to and including that value there. Ooh, negative 2, what am I talking about? Negative 9 to 0, that one. Okay, so we're after a non-one-to-one function, so e to the x is a standard exponential function. Log e to the x is standard logarithmic shape. That's a hyperbola. Sine is that one. So quickly you can see it fails the horizontal line test. So this is not one-to-one. Okay, this one here, a few of you guys got this one incorrect. So if it's going to have an inverse function if this thing is one-to-one. So let's quickly sketch it. 3 and 2 is our turning point, and it's an upright parabola. So it will have an inverse function if its domain is, and set of all real numbers is out because it fails the vertical line test for all real numbers. All real positives union 0 still fails the vertical line test. Now, greater than 2 means it's got this, and then it goes down into the turning point, again failing the vertical line test. No. Less than 3. Well, the turning point's at 3, okay, and all the values less than that chops out this part of the parabola, which does make it one-to-one function. So it's D. And negative 11, well, that would be down here. No, positive 11 rather, and that's going to fail the one-to-one function test as well, or the vertical line test, horizontal line test. All right, heaps of students got this one. You can see it's sort of a bit old course, but the material is just as good. Now, I'm just going to go straight to the answer because many of you had a stab. This is the answer here, I believe. So f of x equals 0. So the value of f of x, or the value of y, is 0 when x is equal to 2 and x is equal to 5. So let's just imagine what f of 5 is equal to. So f of 5, yep, definitely looks like y, or f of x is equal to 0 there. All right, f of 2. Let's do that one. So f of 2, when I put 2 into this, now notice that 2 is hollowed out here, so it gives us this value here. Okay, so f of x equals 0. Oh yes, good. And what I'm looking for is not true. So obviously this statement will be true, this statement will be true, this statement will be true, and this statement will be true. But f of x is not equal to 0 when x is equal to 2, because when I put x is equal to 2 in, this is the value that comes up, whatever this y value is over here. Okay, so this is the one that is not true. All of the other one must be true. Okay, so if you answered something other than C, go ahead and try to work out why you would have been wrong, or why that was in fact a true statement, because obviously at the time you believed that it was wrong, or it was not true. All right, so into the standard simultaneous equation parameter question, which comes up sort of every other year. Okay, so I typically for these questions will note what I've got, which is no solution. No solution occurs when m1 equals m2. We have the same gradients, and c1 is not equal to c2. Okay, now we're going to go negative 3y equals negative ax plus 5. So I'm going to get both of these functions into y equals mx plus c form. Y equals ax over 3, take 5 over 3. Now onto this one, so we've got negative ay equals negative 3x plus 8 take a as the constant, which is y equals negative 3x over, so that's going to be positive over positive a plus 8 take a, all being divided by a, which means that's negative because we're dividing by negative a. All right, let's pair them up. Okay, so what I'm going to do is pair up the m's. So a on 3 is equal to 3 over a. So we're pairing up the gradients. So we're going to get a squared equals 9 by cross multiplying. That means a is plus or minus 3. All right, so we can see here that that really doesn't tell us a lot, because all of them seem to have 3 as an answer, although that can't be true because that's saying all the values other than 3, but it's 3 or negative 3 that are possibilities. This is ruling them out as well. So we're down to 3, so let's just compare the C1 and C2. So to do that, I'm going to say negative 5 on 3 is not equal to negative 8 take a over a. This is rather unattractive, so I'm going to quickly bang this into the calc. It's probably an easy one, but it looks ugly, so I'm going to go solve. Oop. Come on, there it is. Negative 5 on 3 equals negative 8 take a, and that's all going to be divided by a, solving for a. What happened? Pause. All right, this is a bit naughty of me, this one, but I've realized what the mistake was here. This should really be in brackets. Okay, so take away all of 8 take a over a. So I bet you what happens is if I put that in brackets correctly here, whoops, over to the calc. And try it out now. We get a is equal to 3. So that means a not equal to 3, which if you sync it up with this means we rule out a equals positive 3, and so we're going to say a is equal to negative 3 on this one. 5 is, I mean, this question here is really similar to the previous question. So what we're going to say here is 12y equals negative mx plus 24. Y equals negative mx over 12 plus 2. That's my first equation, so that's that one there. And then the other one is my equals negative 3x plus m. y equals negative 3x over m plus 1. Now, what are we doing here? We want unique solution. So unique solution means that for a unique solution, m1 cannot equal m2. Okay, and the y-intercepts C1 and C2, that will force a solution, but the fact of the matter is C can be any number from the real number system and we're still going to get a unique solution. So really what we're looking for is this one only. So I'm just going to equate the gradients. Negative m on 12 is equal to negative 3 over m. Again, if you look at and cross multiply, it just so happens that negative m equals negative 36, m squared rather, m squared equals 36, m is plus or minus 6. Okay, now here we remember what we're looking at is here is m1 cannot equal m2, so these must be not equal to each other. So basically m1 or m is not allowed to equal positive or negative 6. For any other value in the real number system, it will be a unique solution. Okay, so except for these 2 points. So I'm presuming for those 2 points it produces parallel lines or something like that. So that's our answer. Okay, on to this question here. So inverse function. So let's just imagine what this thing looks like. 3, 1. It's got dilation, but we don't really care. And what they're saying is we're taking the values from a value here all the way to positive infinity. Okay, so it's heading in this direction. So I'm presuming it's going to be the values greater than and equal to 3. There it is there. This one was pretty tricky, this one. So let's have a look at this one. System of equations has infinitely many solutions. Okay, so for infinitely many, m1 equals m2, c1 equals c2. That is same gradient, same y-intercept. Right, so again, let's just follow this same procedure that we're following. ay equals negative x plus b, y equals negative x over a plus b over a. So that is this equation. All right, now this one we've got cy equals negative 2x plus d, y equals negative 2x over c plus d over c. All right, let's equate the gradients. Negative 1 over a equals negative 2 over c. All right, so let's have a look at what our options are. A equals C, A equals C, A equals 2C. Maybe let's just quickly do this on the calc. So I'm going to go solve. Negative 1 over A equals negative 2 over C. Solving for A first of all. A is C on 2. A is C. A is C. No, that doesn't look good. So now I'm just going to solve for C instead. C is equal to 2a. Okay, so we're on the right track here. Okay, whoops, what's going on there? Yes, so it's either this one here, A, or it's E. So B is equal to D, or D is equal to 2B. All right, well, what do we know? We know that C is equal to 2A. Now let's equate the y-intercepts. B over A is equal to D over C. Now what we're going to do is we'll substitute in this thing here. So what I'm going to do is say that I'm going to make A the subject of this and get it down to C. So what I want to generate, here's the basic plan of attack. I want to generate the same denominator, so I can pair off the B's and the D's and basically equate both sides. Now, if you have noticed that there is a little bit of mistake in my working here, in my flamboyance to get this right, that should be a take B, that should be a take D, this should be a take B on A, this should be a take D on A. Now the net result was odds. I was still going to get it right because the negatives will just cancel each other out on both sides. So I'm going to presume that that's my intention, although I did stuff it up, but I would have got away with it. Anyway, let's continue with this. So I'm going to say that A is equal to C on 2. All right, now see if you can see where this is going. I'm going to do B over C over 2 equals D on C. All right, so this is going to be the same as 2B over C equals D on C. So because they're the same on both sides, they're the same, so these are the same. So D is equal to 2B. D is equal to 2B. There it is there. Answer is E. Pretty tricky stuff. All right. Graph of the curve y equals f of x is 1 to 1 has exactly one asymptote whose equation is x equals 3. So there it is there. Graph of the curve with that will have an asymptote. So what's going to happen is the asymptote will become y equals 3. So it's going to have a horizontal asymptote at y equals 3. Wow, that's question 16. It's supposed to be hard. Okay, this one, which one of the following functions does not have an inverse function? So same deal. What we're going to do is just roughly sketch each one. That's a root function. That is 1 to 1. This is the truncus, not 1 to 1. It's B. Don't need to check anything else. Graph of the function g with the rule y equals g of x is shown below. 1 to 1 scale is being used. Which of the following is likely to be the graph of the inverse? Let's see if we can predict it. So what I tend to do for these is just sketch the line y equals x. So that's going to kind of do something like that. That's going to kind of do something like that. So looking at the graphs there, that's the same as that part there. It's got to be A. It's just got to be A. So yeah, to do these questions here, I recommend just sketching the line y equals x and just try to reflect. Yeah, come on, scroll. Where are you? Okay, the graph of the function here. So we've got an exponential function, which is the most likely to be the inverse. So it's going to be a logarithm. Okay, so we were after a logarithm. Now it's going to have an asymptote at y equals 1. And let's just quickly sketch this line here, y equals x. So it is going to do something like that. Looks like C is going to be our answer. Yeah, C is going to be our answer. Just trying to think of another way to do this. You could make up a logarithm, an exponential function like this, and then inverse it on the calculator. I can show you something pretty cool here. All right, so what I'll do is go over to graph and table, and I'm going to make up an exponential function. So y equals, say, 2 to the power of x plus 1. Wrong graph. I was wondering why that was a parabola. Okay, there we go. Now there's this cool feature that you can use, analysis gsolve. Where is it again? Sketch inverse. And what that'll do is sketch the inverse function for you. So there's the original, there's the inverse function, and you can pretty quickly see that that's really the only legit one is part C. So it's a really good way of inversing if you've got the function, or are good at kind of making up functions that match what a picture suggests might be the case. Okay, this one here that's pretty tricky. So we'll have an inverse function for, so it's a cubic function. How would we do this? I would sketch it using graph window as well. So let's just clear all. and we'll sketch 4x to the power of 3 plus 3x squared plus 1. Yeah, okay, that's sneaky. Okay, so what you can see they've done, it increases, hits a maximum, goes back down to the minimum. So essentially we want it to be 1 to 1. So we need to restrict the domain in and around this central point here. So what I'll do is I'll just zoom in a bit. So -3 to 3 and -3 to 3, just so we can have a closer look at the behavior. So again, you can clearly see that it's not going to be 1 to 1. It's going to fail the horizontal line test. So how are we going to do it? We could restrict it so we go -infinity all the way up to this turning point here, which looks like it happens at a half. So we could go from -infinity to, that's -1/2, my bad. So -infinity to a half, no, because that's a half there. And that'll include parts of this graph that are not 1 to 1 or will fail the horizontal line test. So that's no, that's no. That's no, obviously. Real numbers is not. -1/2 to +infinity, that would be from here onwards, no, because that's going to include this part here, which will fail the horizontal line test. That -infinity to a half, no, no. This is the only one that's plausible. That's from, I think I've just accidentally moved that. I'll just try to regraph it. A half is there, onwards, yeah, that's the one. Okay, so all of these other ones include portions of the graph that aren't 1 to 1, or that like include this sort of turning point in it, and will fail the horizontal line test. All right, another pretty tricky problem. So what we've got is a sine graph here, and we're looking for when it has an inverse function. Okay, best way to do this one. Let me pause. Okay, so here's how I've tried to attack this one here. So what I've done is basically graphed the function. So I've just typed it into graph window, and there it is there. And what I'm kind of going to do is just test out, like, I mean, you can see that B can't be right because that's plus or minus 1. There's 1, there's -1 and there's 1. Again, this fails the horizontal line test. So what I'm going to do is basically just try, so pi on 12, 3 on 12 is a quarter. So quarter is there, quarter, -1/4. I reckon that's the answer. Cos 1/6, that's 3 divided by 6 is a half, half, half. That includes the turning point. So that's a no. That's a no. Pi on 4, that's 3 divided by 4, 0.75. 0.75, -0.75, no. That's pi on 2, 3 on 2 is 1.5, no way. This has got to be the answer, okay? So how do I know? Well, what I'm doing here is I'm doing roughly 3 divided by 12, which is a quarter, okay? So I'm looking on the graph window here. There's a half, there's a quarter there, so that would be that point there. Right, then we're going to flip to the negative side, which would be around about there. And if I go down, I can see that this segment of the sine graph would be 1 to 1. So it's got to be A. Pretty hard. I can't sort of see an easier way of doing that via algebra or something. I just say, yeah, just have a look at the graph. All right, this one here, we've got g of x is the quadratic, f of x is the exponential, and they want us to form a composition. Look, probably pretty easy to just define the two functions. G of x equals x squared plus 2x take 3. Define f of x equals shift 4 for e, 2x plus 3, and do f g of x. There it is there. And I wonder if simple do an expansion. e to the 2x plus 4x take 3. It looks like it's D. All right, this is also a composition. They want us to stick g of x into that. So it is f gx equals 2x plus 1 all squared plus 1. Leave it at that. Don't expand, don't simplify. Okay, we've got an exponential here, and the inverse of an exponential will be a logarithm. How would I do this one? Maybe it might be good to kind of, all right, let's just do this via that technique I tend to use, which is that. So that's the line y equals x. And what I want to do is a reflection. So that reflected in that line will look like that. And this part will look, or I can't picture this, like that. This will look something like that. All right. Let's see if anything matches that pretty dodgy looking. Yeah, there it is, E. All right. Again, how can you do this on the calc? So let's go over to menu, graph, and what I'm going to do is 3 take shift 4 e to the x and graph that thing. And analysis, G solve, no sketch, inverse, there it is there, pretty clear that that's the only one that even closely resembles the inverse function on the calc. All right, and on to the last one here. So this one here, we've got a hybrid linear function, or the modulus function if you know a bit of specialist maths, but it doesn't really matter if you do or you don't. So how are we going to do this one? Well, what I kind of do with these ones here is just to make up a function for f of x. So y equals x, x take 2, say. So that has 0 and 2. Then, so that's going to be f of x. Then g of x, well, this part of it here is a linear function, and it's got a negative gradient. So that's what I'm going to do here. Okay, so now what I tend to do is I'm going to define them both. So main define f of x equals x times x take 2. Define g of x equals negative x. All right, and it's time to have a bit of fun. So let's go over to graph and table. And what I'm going to do is ask it to graph f of g of x. Let's have a look. Okay, so what that's done, and like I'm only interested in looking at this portion of the graph, so that's the stuff on this side here. So it looks like on this side of the resulting function of the composition, it's going to look like something like that. Okay, so what can it be so far? E is the only one, right? So it's E, that's the answer. But how would I get the full picture? So what I'm going to do is go back into main, just edit my definition to include a positive x on this side. So that's going to be positive x. All right, so now I'm going to redefine it, go back into graph and table, regraph this thing, and consider the left side, which is that. So that's the only part I want on the left side. That's that part there. So that is my resulting graph, is that part there. If you know specialist maths, you'll know that that's the modulus function. So I would just do the absolute value and compose the absolute value function with this, and that'll go straight to it without worrying about the left-hand side and the right-hand side. But yeah, the only answer is E. Okay, so I hope that helped.